What is going on, guys? Welcome back to the MG YouTube channel. I'm Malachi Grubb, CEO of Elite Automation, Elite Properties, and an investor in Tesla. And today I want to discuss with you guys a topic about Robotaxi, FSD, what future FSD versions are we going to get. And I think I have pretty good insight, pretty good prediction of the timeline and at least the reasoning why some of these timelines are going to be there. So a few different things that we have is we have the current version 13.2.9, which is what we're on now. Majority of people are on as far as the newest version of software. You then also have a separate Robotaxi for Austin FSD. And then you have the third, which I'll call version 14, which is the new one with all of the parameters. And I'll kind of go through all those different ones. So, firstly, I don't think that we're necessarily going to get any major FSD revisions on version 13.2.9. And if we do, it's going to be very small, minor changes. And I also want to explain the ecosystem of how FSD works and how it's trained. Okay, more specifically how it's trained. And the thing is, FSD is being trained basically on supercomputers, on AI supercomputers that are built especially for this. You know, you see that like Tesla's building huge infrastructures of data centers that's basically doing nothing but AI training. XAI is doing the same thing. You know, Facebook and all these big dog companies are spending billions of dollars on these AI data centers. Why are they doing that? It's because they need that much compute to train these AI models. It just takes that much compute power. So part of the reason why that's important to know is the AI compute then becomes the resource, right? The resource being like the equivalency of $1. It has such a fundamental impact on the direction of the company. And I'll break that down a little bit more. For example, they just started working towards, or they are working towards a version 14, which would be a new model that we potentially get later this year. Okay, version 14 has a lot more parameters on it. That version 14 has to train independently of the version 13. And also, while training, it is highly likely that they have to train multiple sub-models, right? So, like, let's say, for instance, you have version, 13.2.9, but in the same time, they were before we got .9, I'm just giving an example's sake, they were training .6, .7, .8, and .9 all together at the same time, right? And then whatever version ended up working out as being the best AI structure based on like the learning parameters they gave it, that's then the AI they determined to deploy. So there was probably 3 different AIs that got killed off, even minor revision AIs that got killed off. And that all takes compute resource, right? Every one of those minor revisions, every one of the major revisions, they all take compute resource. Now, the reason why I think version 14 is going to take such a long time to get is because of the parameters of that version 14. And I don't think we're going to get a new version of version 13 unless it's just like small minor changes, bug fixes and stuff like that, because I don't think they want to allocate the resources towards FSD that we currently have, right? Now they have this big, extremely more powerful AI in the version 14, that's what they want to launch, right? They have to be forward projecting and focused towards like, okay, our current customers have this, but we're really, future driven. We're really focused towards like what's going to be the best outcome in a year from now. which is one pro and con against Tesla. You know, it's a pro for like investors because they're forward thinking. So you know that 5-10 years down the road, that company is gonna, you know, only grow and only be ahead of everybody in tech. As a user, it sucks because now we gotta wait 6 months before they give us any new software version in our FSD. So we don't get any improvements until they probably decide to drop us the new version 14. And so I want to dive deeper into like the parameters and why I think that it's going to take so much time for them to release version 14. But before I do that, I want to talk about Robotaxi FSD and what the difference of that is. So what I predict the Robotaxi FSD is it's either the most recent version, 13.2.9, and then maybe it's gotten flipped to like another revision above it. But I think what's happening there is they basically are hard coding and or giving instructions for Robotaxi, meaning, you know, generalized autonomy is performing really well, all across the board, and then we're going to go down to Austin, Texas itself. So in Austin, Texas, it's performing really well. However, there's a total of, let's say, 50 intersections that are not performing great. By the way, we're in the Cybertruck in FSD, been in FSD the entire time. I don't want to get off topic, I just want to let you guys know I'm in FSD. So what I project they're doing is they're hard coding FSD specifically there in Austin to accommodate for those, let's say, 50 intervention conditions, right? And so they're basically telling the car, this is what you should do. This is how you should handle that. Now, whether they're training that and then building it into the AI model, where they're like manually teaching, there's two different things that could be happening. They could be either manually teaching, no, do this at this intersection, no, do this at this intersection, no, do this at this intersection, right? Manual human training, which is one plausibility that they could be doing. And then the other thing is like actual hard coding. So like basically when we come to this intersection, we jump over here and we run like some C++ type of hard coded language, or another AI model layer that sits on top of our current FSD that we have. So we have the current FSD that we have. Basically there's some triggers that say if we reach this intersection, we're going to jump into this Austin FSD that's then going to correct this one particular issue that has just like some, you know, specific code changes for those instances. Now, I would assume that they are definitely doing the manual training or the hard coding, because they're not going to get a generalized model. Even if they did another AI model on top of the current FSD, I don't think they're going to get that model to act right without the human teaching saying, you know, you need to do this, no, you need to do this, no, you need to do this. So that's one thing that I project. I also don't think we will ever see that FSD in any of our Teslas. I don't think, which this gives me another projection too, that I don't think that we will see FSD, I don't think we'll see FSD unsupervised in our cars for an extremely long time. I think that we're probably not going to see it until version 14. So I think they want us to have a true, general autonomy that works without having to add that layer for Robotaxi. Now, there is a plausibility that they would give Austin, Texas members, or like Geofence, anybody in Austin, Texas, to have the Robotaxi FSD, but I think it's not very likely, because I think they're more worried about, let's show shareholders, let's show investors, let's show the world that we can do this FSD thing and this Robotaxi thing, and they really don't care about me and you being able to use FSD at this moment. They care about getting Robotaxi launched and Robotaxi being a business and revenue stream for Tesla, right? That way it can drive the stock price up and also just show up as revenue, and it's going to be extremely profitable. It's not going to be just a huge revenue stream, but it's going to be a huge profitability stream, and that's going to start taking away from other market shares like Uber and Lyft and stuff like that. So that's the main thing they want to try to accomplish is really just, again, showing the world that Robotaxi is ready, and they're doing whatever they need to do to make that happen. Now, going into the version 14 with these mass amount of parameters, part of the reason why I think that version 14 it needs so much work is because whenever they go to a major revision, they basically kind of change the underlying model of the AI. And there's a few different reasons for changing the underlying model. One, they understand that they got to identify new things that they couldn't identify before. Secondly, there's going to be hardware constraints, and I'll say hardware and software constraints. So maybe like, say for instance, version 14 can't run on a certain vehicle, or let's use a perfect example. People on hardware 3 are not even getting the newest version of the software. And it could be a plausibility, just onboard compute is the issue, not the cameras, not anything else other than the compute itself on board is just not capable, right? They just need they need a stronger computer. Like how they're talking about like Dojo and Dojo coming out with new computers, and like, they're about to come out with, the Dojo 2, and then, they're saying Dojo 3 is going to be like even better than that, or like 10 times better than that, that the third iteration of a product or technology is substantially better. So, you have that constraint of the AI compute on board. That's going to be one of your biggest constraints, because cameras and 4K cameras consume a shit ton of data, and the processing of that data just takes a ton of compute. So that's one thing. And the other thing that's there, and I think that Elon had mentioned this directly, is that it's going to take a lot more polishing, and they need to optimize the AI, the AI efficiency. So you can have this AI that can run on the supercomputers that they have, right? And it has no problem running on the supercomputers that they have, but as soon as you try to put it into a onboard like Dojo computer, it doesn't have it. The AI model can't run on it without like maybe crashing or just having issues like that, right? So now they have to find a way to kind of condense that model to be more efficient, or just find ways for that model to be more efficient. And so you're kind of working with those two different things: advancements in compute for the vehicle itself, and then also advancements in the software itself and it being able to operate more efficiently. So that's two of the things that are there for as far as the version being able to run and operate on different vehicles and stuff like that. And so I think the part of the reason we're not getting it for some period of time is because they need to make it more efficient for it to be able to operate appropriately on our vehicles, just efficiency-wise, and not crashing the computer and all that. Not even functionality of the FSD, just that aspect of it, just data efficiency. And then, hey guys, I'm shooting. And then another huge thing that's there is that version 14, or anytime they go from any major version where they change like the base model, I think they pretty much have to scrap everything. They take what they've learned from previous things and they include the things that they learned in the previous models in the new model, but all the data training is all gone. It's done. It's not usable. And I'll tell you why I'm like almost 100% confident in this. It's because, for example, they're adding more parameters, okay? So let me explain parameters, and then I'll jump back into that one. So a parameter could be a lot of things, and I wish they would give us a better definition of what their parameters are, but I want to give you some examples of some parameters, right? A parameter could be anything like a stop sign, could be lines in the road, could be, you know, striped lines, solid lines, could be a U-turn sign, could be, right? All these things could potentially be parameters, right? And so if they're adding more parameters, that gives the AI the ability to understand more things, right? And then the AI makes a decision based on that understanding. And then somebody might say, well, why can't they just take all the learnings they did before, all the training they did before, and then just stack, you know, the new thing on there? Well, the reason why that doesn't necessarily work is because, let's say, for instance, the vehicle does not, let's see a no U-turn sign, right? As of right now, I'm just giving you an example. The vehicle does not see a no U-turn sign, so the vehicle takes a U-turn at that no U-turn intersection or location, whatever. Now, with that being said, that now basically interrupts what the next path of logic would be, right? Because if I'm going to take this left turn, or I'm going to take this U-turn, then, you know, it's a couple things. Okay, slow down, take the left, take the left, watch for cars on the right side. Okay, now I can go. All of those things basically get eliminated down the chain because we're not taking the left anymore. We see the no U-turn sign and we can't take a left, so we have to go straight. And so it just disrupts any next steps that the vehicle may have had. Again, parameters, I gave you examples of like some signs or something like that. Different or lines in the road. Those are physical things. Some other parameters could be speed-based, distance-based. How far am I from the vehicle in front of me, right? And so a lot of those things, it's going to change the next steps. How far does the vehicle need to be from me before I take a left turn in front of that vehicle, right? How much do I need to accelerate to get to there, right? Or let's say, for instance, let's say, for instance, an older model does not examine the speed of a vehicle. They just measure the distance of the vehicle. Says, okay, if the vehicle's 100 feet away, I can pull out. If it's 50 feet away, I can't pull out. Now, let's say we add parameters to that and we say, if the vehicle is 100 feet out and going 60 miles an hour or less miles per hour, more distance, I can pull out. If it's at 50 feet away and going 30 miles an hour, so 30 miles an hour or less, or a little bit more than 50 feet, I can pull out, right? So now we gave the ability for the vehicle to make a decision that it can pull out at 50 feet versus the used to be only at 100 feet, but we have the new parameter of how fast is the vehicle going that's coming, right? So the vehicle that's coming towards me, how fast is that vehicle? Maybe in the past, like, we're not even looking at what's the speed at which that vehicle is. Maybe for making a right turn. Maybe the parameter's been there for like behind us. And we know, again, I just don't want to use examples. I don't want to get into too much like technical because some things are already there, right? Okay, and then let's say, for instance, we're looking at something like, we know that vehicle's going 60 miles an hour. Now, the next decision is, instead of accelerating, right? And so, like, let's say, for instance, the vehicle has an acceleration curve, like, so how fast it goes from like 0 to 60 or whatever it may be for like an interstate. You have your acceleration curve. And so instead of, like, let's say, for instance, in the past, that acceleration curve has just always been kind of a flat acceleration curve. A big complaint against Cybertrucks, right? Cybertrucks are super fast, but yet they kind of like don't use any of that acceleration to get you through and to get you through an intersection or get you like out in front of somebody. Like, it'll pull out in front of somebody and then like be slow. So the next thing is like, okay, that vehicle's going 60 miles an hour. I'm using pre-inputs, right? that vehicle's going 60 miles an hour, it's 100 feet away, I'm going to pull out. I have to make sure that I reach, I'm going to just use matching numbers, I have to reach 60 miles an hour in 100 feet to make sure that that vehicle that I just pulled out in front of doesn't have to stop in front of me, right? And so that whole sequence of what just happened there, that input that we seen and that output that we got for like adjusting our acceleration could not happen because the stack wasn't there in the past for us to like make these adjusted calculations based on like a previous data to make a different output decision than what we had previously done. So that's like one thing that I think people don't really understand about AI, and it's like very confusing about AI versus like hard coding. If this was hard coding, we was just making an if statement that says if vehicle this speed, this distance, do this, that's not a problem. We can go in there, just edit that code, adjust, done. The thing is about neural nets is neural nets are trained, and the kind of one downside to them is a lot of times neural nets, we don't have access to why it's making the decision. We don't have access to the decision itself. My understanding is we have those parameters, and those parameters are like an input table and an output table. In those things, we have the ability to see and influence, but not necessarily change anything behind that, right? So the vehicle makes its own decision based on how it thinks it needs to make its own decision. The AI makes its own decision. But the
It's called work. It's in Python.
where was I going with this? Oh, but the but we're just not able to directly edit it the way that you can a regular, text-based code. So this creates major limitations with like being able to transfer any of the learning and stuff. Sorry, let me take it back. Not learning. The ability to take any of the training, the AI training, and convert it over to the new version. So kind of like bringing things full back circle. These models have to run separately. They have to use some dedicated amount of compute for each one of them. Training the new model is much more important than trying to make improvements on the other model. I mean, like, we can just run numbers. Let's say, for instance, you ran 50% and 50% on version 13 and version 14, right? Now you're half as likely for version 14, or you're going to take double the amount of time for version 14 to be ready, just due to AI compute constraint. Now, if you take that and you reduce it to, we do 10% version 13, 90% version 14, now there again, now you just like have completely off shifted. Let's say, for instance, we do 1% version 13 and you do 99% version 14. So now you're basically going to be near to 100% faster at getting V14 ready by not training V13. And also, in the meantime, the other one you have to throw in there is, a couple other ones actually, is you have to throw in the Robotaxi. If that version's having any AI training going on with it, that compute is gonna take a lot of compute power. And then another big one that's not related to FSD at all, and I don't think I've heard anybody talk about this, is Optimus robot. Its AI compute is also having to be shared there as well. And so they know that the Optimus is one of the most important things they have going on, even more important than FSD. However, in my opinion, the way that the company is going to execute over the next 10 years is Robotaxi is the stepping stone. So the first stepping stone was the vehicle, FSD, Robotaxi, Optimus robot, right? And so all these are just stepping stones to either like generate enough revenue to keep it going, and also buy time for them to get the other thing ready. So like Optimus is just going to take them so much time and development. Like let's say for instance, if they drop everything they were doing in Robotaxi, it's going to take them 5 years, let's say, to get them like fully functional, where people can really use them and really be happy with their uses and like have a lot of general use cases. I think they'll be ready in a couple of years with like some specific use cases. But okay, going back to that though, you know, FSD is the stepping stone, so that they have to share the amount of compute between the, you know, Robotaxi version 14 and Optimus. And some of that might be that they're like all in the exact same data center, and it's just like limited, based like software limited, like you get this much resources, that you get this much resources. Or it could be something where it's like Optimus is trained in this AI data center, and then all FSD things are trained in this AI data center. But either way, it doesn't really matter, right? Whether it's software limited or whether it's physical location limited, you know, those resources are major resources. Again, they're spending billions of dollars on these resources, so they're going to spend, if they had to spend another $1 billion to build another Optimus data center, then that's resources that Tesla's allocating that they could have also allocated the resources to FSD instead. Or you know, or again, they could be version 13 versus version 14 of FSD, or some Robotaxi version of FSD that might be slightly different than what we have. Again, I think Tesla's long-term goal is they want to use our version of FSD as Robotaxi FSD. So like version 14 will eventually be part of Robotaxi FSD, because they really want, I think, to accomplish the true, they want to accomplish the true generalized autonomy for vehicle driving. I think another huge one that should be there, and I really hope that they have it in the version 14, is memory, right? It needs to be able to recall locations. If I've been down this highway before, recall this, so that way it can make more predictive analyzations. Maybe if, like, for example, if it's raining or something, like if I can use GPS data and use signs for locating, then it might make it even better for me to, or make FSD be able to perform even better during like a rainy condition, and or if there's like a pothole or something and I go to swerve over, I have to disengage to avoid a pothole. That it then says, oh, there was a disengagement. What was it? Oh, I think I identified a pothole, and into the future it always just kind of swerves around it, right? Especially if you do something 1, 2, 3, 4, 5 times or something like that, it should then never do it again. It's kind of like mind-blowing that there's not really much memory, where like if every time I have to correct it for something, why is it not like auto-correcting itself? So I'm hoping version 14 has some memory. I don't want to get too far into that. It's like kind of a whole another topic. Then like, you know, the different versions of FSD and version, you know, and how they're, hey guys, hey, yeah, how they're executing the different training for the different versions. Hopefully this is like insightful for everybody. I had a prediction that I wanted to also put out there, but I forgot what it was now. I guess you have to subscribe so I can remember and put it on the next one. But yeah, again, I hope this is really insightful and, like, you know, opens people's eyes to some of the ways that, like, you know, the data has to be executed, and the way that the AI models get trained, data resources, vehicular resources, and like why we're getting versions at different times. Version 14 is likely to come out later this year. It's likely not what's being used on Robotaxi. The only way I would say that Robotaxi was on maybe a version 14 is if it had a bigger computer in it, or two computers, dual computers or something. But according to Elon, those are coming off the line, like the same as mine and yours would come off the line. They just have a different version of FSD. And these are things that came directly from Elon, so that's not like stuff that I'm just making up. It either came from like Elon or like the FSD team or something along those lines. So yeah, again, hopefully this was enlightening. If you'd like to see more videos like this, make sure to subscribe. And also too, I'm open and interested in jumping on other people's podcasts, stuff like that. I'm open to having people on our podcast. We have our Elite Automation YouTube channel as well that we've done podcasts and stuff in the past, but that's like manufacturing base related stuff. So like this channel here is more like Tesla and business entrepreneurship and things like that. So yeah, catch you on the next one, and good talking to you.